In this video, we're going to look at a skill called rationalizing a denominator. Okay, again, it's called rationalizing a denominator. And I'm going to kind of describe what it is first before I tell you how to do it. Okay, so again, I'm not expecting you to understand how to do it right now, just I want you to understand what it is that we're going to do. Okay, all right, so if you had a fraction that looked like this, let's say we had the square root of 3 divided by the square root of 2. Right? Rationalizing the denominator would be taking this fraction and changing it into another form. Right? And it turns out that radical 3 over radical 2 is the same thing as the square root of 6 over just 2. Okay? And so rationalizing the denominator is this skill where we can turn something like this into another form, right? Like this. Right? And these two fractions are equivalent, right? They have the same value, right? They just look different. They're just in different forms, okay? And rationalizing the denominator is what we would do to get this to be like this, right? And why would we do that? Right? Well, the reason is because in some types of math, we actually want to avoid having a square root or any type of root on the top of a fraction and on the bottom of a fraction, right? And in some places in math, especially in trigonometry, you want to have fractions that only have a radical in the numerator, right? So this will be especially important in classes like math analysis or trigonometry, right? Again, the idea is that you want to not have radicals in the denominator. So you want to rewrite this in an equivalent form, right, that only has radicals on the top. Okay, and let me do kind of a side. Let me kind of show you something to the side. Right, I want you to think of what we're going to do kind of like this. Right, imagine we had the fraction 3/4, right, and we wanted to write another fraction that has the same value as 3/4. Right. Well, what you could do is you could multiply this by, let's say, 2 over 2. And get the fraction 6 over 8, right? And hopefully you recognize, right? 6 over 8, that's the same thing as 3/4, right? And it's really simple, right? You could just reduce 6/8 and you get 3/4, right? Or you could, if you wanted to, take 3/4 and you could multiply by something else. We could multiply by maybe 5 over 5, right? And that would give us 15 over 20, right? And again, you could reduce this, and you would get back to 3/4, right? So 3/4 and 6/8, 3/4 and 15 over 20, those are all equivalent. They're just different ways of writing the same fraction, right? And you might think, well, when we multiplied, didn't we change the fraction? Right? And we changed the way it looked, but we didn't change the value, right? Here's a really important thing for you to realize, right? What is 2 over 2? Right? Well, hopefully you recognize that 2 over 2 is just the same thing as 1. And what is 5 over 5? Well, that's also just 1. So when we multiply by 2 over 2, we're just multiplying by 1. Right? When we multiply by 5 over 5, we're just multiplying by 1. So again, 15 over 20, it has the same value as 3/4, but it just looks different. Right? It's in a different form. Right? And it's going to be the same thing when we're rationalizing denominators. Right? Radical 3 over radical 2, it looks different from radical 6 over 2. They're in different forms, but they have the same value. And what we're going to do is we're going to multiply by a special form of 1 to get from one format to the other. Okay, so that was kind of my quick little explanation of what this is about. Right? Now I'm actually going to show you how to do this. Okay. All right, so we have this radical 5 over radical 3. And what we want to do is we want to multiply this by something so that we don't have a radical in the denominator. Right? So I want you to kind of think, what could we multiply radical 3 by so that you would end up with a whole number in the denominator? Right? And the answer is we would take radical 5 over radical 3 and we would multiply by radical 3 over radical 3. Okay, why? All right, well, let's think about what this comes out to be. Right? Well, if I multiply the top, radical 5 times radical 3, that comes out to be radical 15. What do we get on the bottom? Radical 3 times radical 3. Well, that's the same thing as the square root of 9, but what's the square root of 9? Square root of 9 is just 3. All right, and that right there is our answer. Okay, so radical 5 over radical 3, that's the same thing as radical 15 over 3. Right? They just have the same value, they're just in different forms. Okay, and the value of this is that we don't have a radical in the denominator. Okay, and just like with the other fractions we're looking at, think about what this value is. Radical 3 over radical 3, that's just 1. So we didn't really change the value because all we did was we just multiplied by 1. So again, this has the same value, it just looks different. Let's look at another one. Okay, we're going to multiply by something so that we don't have a radical in the denominator. All right, so what should we multiply by? I've got 7 over the cube root of 5. Right, I want to multiply by something so that I will not have a radical in the denominator. Right? What would I need to multiply by? Okay, and the answer would be radical, or the cube root of 5 times another cube root of 5. Why is that? Let's think about that. Take a look at this bottom, right? We have a cube root, right? And if we multiply this, what's the cube root of 5 times the cube root of 5 times the cube root of 5? Well, that would be the cube root of 125, which you should know is 5. Right? So basically what we're doing is we're thinking about how many more 5s I need in order to make this come out to be a perfect cube so that it comes out perfectly to just be an integer, a whole number here. Okay? On the top, I would have 7 times the cube root of 25. Okay? But that's not the important part. The important part is the fact that this, when you multiply this, comes out to be 5. Because I have now 3 of these factors, 3 of these cube roots of 5. So when you multiply that together, you just get 5. All right, this is your answer. All right, I'm going to do one more, and then you're going to try some on your own. Okay, so I've got the cube root, or I'm sorry, the 5th root of 3 over the 5th root of 125. Right, and before I think about what I want to multiply by, I think it'd be useful to remember. Right, this is the same thing as, well, what's the 5th root of 125? Well, that one doesn't come out perfectly, but if we were to factor that, isn't that the same thing as the 5th root of 5 times the 5th root of 5 times the 5th root of 5? Sorry, you can't see that too well. Okay, let me try to rewrite that. Okay, so again, 125 we know is 5 times 5 times 5. So I can rewrite this bottom as the 5th root of 5 times the 5th root of 5 times the 5th root of 5. Okay, so what would I need to multiply by so that on the bottom I would not have any more radicals? Okay, what I would need to multiply by is, well, let's think about it. I'm taking a 5th root. So how many 5s do I need to make this come out perfectly? I already have 3. I'm going to need 2 more. So I'm going to multiply by the 5th root of 5 times the 5th root of 5. Okay, on the top and the bottom. And again, I need that on the top and the bottom because what is this equal to? This is equal to 1. I need to multiply by 1. Right? And so on the top, that would be the 5th root of 3 times 5 times 5, 75. And on the bottom, what does this multiply out to be? This multiplies out to be just 5. Okay, and there we have it. We have another form of our original problem, but I don't have any radicals in the denominator. All right, I want you to try to think about this one. Pause and see if you can rationalize the denominator here. All right, welcome back. Let's see if you got it. So first, let's rewrite this. This is the 6th root of 7 over the 6th root of 16. All right, and if you want, you might want to do this off to the side. 16 we know is 4 times 4, and I could again factor this as 2 times 2. This is 2 times 2. So let's rewrite this as the 6th root of 2 times the 6th root of 2 times the 6th root of 2 times the 6th root of 2. Right? I've got 4 factors of 2 here on the bottom. Okay, so what would I need to multiply by so that I do not have radicals in the denominator? Right? Hopefully you figured out that we need 2 more 2's. So I need to multiply by the 6th root of 2 times the 6th root of 2 over the 6th root of 2 times the 6th root of 2. Right? And if I multiply this out, I would get for my numerator, I would get the 6th root of 7 times 2 is 14 times 2 is 28, the 6th root of 28. And what would I have on the bottom? Well, the 6th root of 2 times 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 6th root of 2, that's going to be 2. Last one. Again, I want you to pause and see if you can figure this one out. All right, let's see if you got it. So first, I'm going to rewrite this. So this is the same thing as saying 2 over the 5th root of, well, 9 is 3 times 3, so I'm going to rewrite it as the 5th root of 3 times the 5th root of 3. Okay, so what do I need to multiply by so that I'm not going to have radicals in my denominator? Well, I have 2 factors of 3 here. I'm going to need 3 more. So let's multiply by the 5th root of 3 times the 5th root of 3 times the 5th root of 3 over the 5th root of 3 times the 5th root of 3 times the 5th root of 3. Again, make sure you show this because it's really important to show that we're just multiplying by 1, right? Because we don't want to be changing the value. We're just changing the way it looks. Okay? And if you multiply this out, on the top we would have 2 times the 5th root of 27 over, well, what do we get from the bottom? 5th root of 3 times 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 5th root of 3, that should be 3.